Today we will be in Chapter 9, Section 5, Systems of Linear Equations, Applications. Our topic objective for today is to use systems of equations to solve applications. Okay, for today's notes, 9.5, Systems of Linear Equations, and those are application and problem solving. That means you're doing word problems today. So because we're doing word problems, I actually posted kind of a handout that will help you take the notes, and basically we're just working through a set of problems today that are exactly like the ones on your homework. So you need to get this paper opened or printed off or something so that you can be able to work these. So if you go into course documents and videos once you're in our site, you click that, then you see that there's this button called Handouts, and you can select that, and then it's got a set of handouts that you can use throughout the semester. We are in 9.5 and there's a handout, and then I even posted an answer key so you can open both of those if you'd like and be able to work through these and everything like that on your own. But I'm going to open 9.5 and then we're going to work through these together today. Okay, here's the handout for 9.5. Again, it's just a set of problems that we're going to work through today, so there's really not a lot of notes today because the things that we are doing today we covered back in Chapter 3, primarily Chapter 3, 1, 3.2, and 3.4. But the difference is when we did word problems back in Chapter 3, we didn't know yet how to do systems of linear equations. So now we're going to do a lot of those same problems, but with the systems of linear equations. And so that's what these are. There's a land area problem, a concession stand problem, a rowing speed problem, a mixture problem, and then an investment problem. So there's only 5 problems, and that's all we're doing today in our notes. And then I'm not doing any of the homework because these are just like your homework problems. So we're just going to work through these. Hopefully they're not as hard or as scary as the ones in Chapter 3 were, just because you've had these before. Okay, so pull up my paper so you can see what I'm going to be doing. And let's work through this. It says the combined land area of Grenada and Guam is 890 square kilometers. The land area of Guam is 200 square kilometers more than the land area of Grenada. Find the land area of Guam and Grenada. So of course we have two countries that both start with G, so we can't let one of them be G, and so what I'm going to do is I'm going to assign them, there's Grenada and Guam. I'm going to assign them each a letter so that we can write equations for these. So let's say Grenada's A, Guam's B. If you don't like those, you can make them whatever you like. But I'm going to do that so we can get through this problem a little bit simpler. It says, the first line says the combined land area of Grenada and Guam is 890. So when you combine something, that means you're going to add them. So we are adding Grenada and Guam, and we said that that's 890 square kilometers. The second line says that the land area of Guam is, and whenever you see an is in a word problem, remember that's your equal sign. So Guam was B, so we said B is 200 square kilometers more than the land area of Grenada. So we have 200 more than Grenada, so 200 plus A. Find the land area of Guam. Now, in these problems, you can do these multiple different ways. Right now, we have two equations, two unknowns, and so we have a system of linear equations. We could just say, okay, we know B is this 200 plus A, and we could plug that in and then work it out, and that's the substitution method. So you can do this through the substitution method, or you can do it through the addition method. I'm going to do it through the addition method just to kind of be a little different than how we did it in Chapter 3. And I want to show you that you can do it this way, okay? So in order to do that, though, we need to have them written as a plus b equals something. So it means we need to move this problem around. So I'm going to just rewrite the first equation. A plus b equals the 890. Then I'm going to, if I subtract my a over, I would have negative a plus b equals 200. Remember, from the previous sections in Chapter 9, if you're doing the addition method, you want one of your variables to disappear when you add them. So right now, if we added our a and our negative a, those would go away. So this makes it a really nice problem, because we can just go ahead and add them, and we'll get 2b equals 1090. So if we divide both sides by by 2, you're going to get b equals 545. Remember, b is Guam, so that's Guam. Guam is 545 square kilometers. So now we need to know what a is. From our first equation, we know that a plus b equals 890. Slide that up a tiny bit. We just found out our b is 545, so let's put that in where the b is. I need to subtract 545 from both sides. So I get a equals 345, and a was the square miles of, or square kilometers of Granada. Okay, so this is if we did the addition method. And those are our answers. And since we're only doing 5 problems today, I will go ahead and do this the other way. So this is addition method. So let's do the substitution method. Same problem. 2 different methods, so you can see which method you like, which method you prefer. I'm just going to copy down our system of equations. We had the a plus b equals 890, and we had b equals 200 plus a. Okay, for substitution, that's where you set one of your equations. You get one of the variables by itself, and then you just take that and plug it into the other equation. So anywhere there's a b in that first equation, I'm going to put in 200 plus a. So it becomes a plus 200 plus a equals 890. I'm going to combine my a's, and that'll be 2a, and then I'm going to subtract 200 from both sides. So that becomes 690. I'm going to divide both sides by 2, and I get a equals 345. And remember, a is Granada. Right there, we got a is 345, and up here we got a is 345. So that is a very good sign for the second one. We know that b equals 200 plus a, so that's the equation I'm using. Guam is 200 more than Granada, so that'll be 200 plus the 345 that we just found. So that means b is 545, and that is Guam. And that's exactly what we found on the first one. So you can do either method when you're doing these problems. You can do the addition method, which is the way we did it the first time, or you can do the substitution method, and it can work either way. Depending on your numbers and how the problem is, you might want to use one method over the other. But that is how you do number 1. So let's move on and do the concession stand problem. Okay, the concession stand. At the concession stand, there's 10 hot dogs and 4 hamburgers cost $19.50. 4 hot dogs and 10 hamburgers cost $22.50. And then we need to find the cost of just 1 hot dog and 1 hamburger. So let's determine what variables we're going to use and then write out our system of equations and solve it. So we have hot dogs and hamburgers. Those are our 2 variables. So they both start with H's. So I'm going to let hot dogs be a D, and I'm going to let hamburgers be an H. Again, these are just the ones that I'm choosing. If you have other letters you want to do, you can do that. So at a concession stand, it says 10 hot dogs and 4 hamburgers cost $19.50. So that means we have 10 hot dogs plus 4 hamburgers equals $19.50. That's what that first part says. The second part says we have 4 hot dogs, so that's 4D. I'm getting confused in my own letters. Plus 10 hamburgers equals $22.50. So that is our system. Now we need to know how much 1 hamburger and 1 hot dog costs. So in this case, I am going to do the addition method again, because if not, I'm going to have fractions, and I really don't want to play around with fractions. So when you're doing the addition method, remember you got to get one of your variables to go away. So you either have to get your D's or your H's to go away. And it doesn't really matter which one. But I'm going to try and get my H's to go away. So I need my 4H and my 10H to go away. So this is one of those problems where I'm going to have to multiply each equation by something to get them to go away. So I'm going to multiply my first equation. I'm going to multiply that by 10. Because if I multiply that by 10, I get 40. And if I multiply this bottom one by 4, I would get 40. But I need one of them to be negative, so I'm going to multiply the bottom equation by a negative 4. Because remember, I need that H column to go away. Again, if you need refreshed on this, look back in your previous sections of Chapter 9. Okay. So if I'm taking 10 times 10, that gives me 100D, plus 10 times 4 will give me 40H, equals 19.5 times 10 will give me 195. Multiplying by negative 4 on the bottom, I get a negative 16D minus 40H equals a negative 90. Again, you could have multiplied by a negative 10 on top, or you could have chosen to get rid of your D's instead of your H's. There's a lot of options to do on this problem, but I decided to get rid of my H's, and those are all going to go away. So 100D minus 16D is 84D, and 195 minus 90 is just 105. So now I have 84D equals 105. I have to divide both sides by 84, and I get D equals 1.25. And remember, D is my hot dog. So this is $1.25 per hot dog. So there's the cost of my hot dog. Now I need to find out the cost of my hamburger. From the very beginning, we knew that if we have 10 hot dogs and 4 hamburgers, it's $19.50. And now we know what a hot dog is, so we should just be able to plug it in and solve it. So I'm going to rewrite that first equation. Again, you can use the second equation if you like. It's up to you. But you have 10 times, and now I'm going to put in my 125 where my D is, then plus the 4H equals 19.5. 10 times 1.25 will give me 12.5 plus 4h equals 19.5. Subtract both sides by 12.5 and you get 4h equals 7. Divide both sides by 4 and you get h equals 1.75. Remember, h is the cost per hamburger. So a hot dog costs $1.25 and a hamburger costs $1.75. I say we need to go to these concessions every time we go to a game because that's really cheap. Okay. Again, if you need to see this reworked again, obviously you can just rewind the video and listen to me tell you how to do it again. And you can also open up the extra handout, the 9.5 handout with the answers on it, if that helps you. I have them typed out there as well. Okay, we're going to move on and do rowing speed. Okay, so let me pull up my paper and I'll move it. Okay, we have the Smiths are canoeing on the river. They travel at an average speed of 4.75 miles per hour when paddling with the current and 2.25 when paddling against the current. Determine the speed of the canoe in still water and the speed of the current. Okay. This one's a little hard just because it sounds really strange. But let's define what our variables are. What are our unknowns? Well, we need to know what the canoe's speed is, and we need to know what the current speed is. Again, just like every other problem we've had, they both start with the same letter, so that does not help us. So I am going to call the canoe speed is an S, and the current speed is a C, because your canoe speed, it's kind of like your speed in your car, and then the current is just the current. So, we know from our problem that the Smiths travel at 4.75 miles per hour when they're paddling with the current. So when you paddle with the current, that means you are going whatever speed you're going, and then you're also adding to that the speed of the current. So that means we'd have S plus C equals the 4.75. It's kind of like thinking about walking on an escalator. If you actually walk on an escalator, you're going to go whatever your speed is plus the speed of the escalator, and that's going to give you your total speed. So that's how this problem is working. Now, when you travel against the current, you only go 2.25. So, what do you think the first part of that problem is going to say? You're going to take your speed and you're going to subtract the speed of the current. And that's going to give you your 2.25. And there's our system. This one's already set up to be a really nice addition method system of equations, so let's use that method. Let's just draw our line, and we can automatically get rid of our currents if we add it. So that'll give us 2s equals 7. Divide both sides by 2, you get s equals 7 over 2, which equals 3.5. And then our s was the speed of our canoe. So that's miles per hour. And since that's the speed of our canoe, that'll be the speed in still water. Because our question says determine the speed of the canoe in still water. So if we're not adding current or taking away current, we are going 3.5 miles per hour in still water. So there's half of the answer. Now we just need to find out what the speed of the current is. So we said at the beginning that our speed plus the current is 4.75. So we just need to substitute in the 3.5 for our speed. So we have 3.5 plus the current equals 4.75. Just subtract both sides by 3.5 and you get current speed is 1.25 miles per hour. And that's the current speed. So this problem I work out specifically because the moving with the current and against the current can be a little bit confusing. But the problem itself wasn't actually bad mathematically. Okay, we're going to move on and do the mixture problem, which is everybody's favorite. I know. You're all jumping in your seats at home. So, I know you love these, and I'm sorry, but there is a mixture problem on your final, so you do want to make sure you know how to do these mixture problems. Don't stress yourself out over them, though, because you do get a cheat sheet, so it is nice if you use this as a study point. Okay. It says that Dr. Chung needs to create a cleaner containing 30% trisodium phosphate TSP. Chung needs to mix 16% of the TSP solution with 72% TSP solution to get 6 liters of a 30% TSP solution. How many liters of 16% and how many liters of 72% solution will he need to mix together? Okay. So just based on the very last line, how many liters of the 16 and how many liters of the 72, hopefully, since we've done enough word problems, you know that right there, those are going to be your variables. So we have number of liters of the 16%, and then we have number of liters of the 72%. Those are our two variables. So I'm just going to call the first one X and the second one Y. Okay, and if you remember back to, sorry, my paper got moved. Chapter 3, I always drew out a graph, a table for these mixture problems because it made it so much easier. So I'm going to do that again here. I'm going to draw a a table to stick all of our information in it because it makes it so much easier. And I really recommend you doing this on your problem. Obviously, because I'm taking the time to do it on my problem. So, our first column, if you remember, is solution column. Our next column will be our strength column. Then the number of liters. And the last column is amount of TSP. Okay, so we have solutions. We have 3 solutions actually in this equation. We have a 30% solution, a 16% solution, and a 72% solution. So we have our 16% solution, our 72% solution, and then we're combining those, and that's going to give us our mixture, right? In your strength category, that's where you're putting the strength of your solution. So like our 16% solution has a 16% strength, but you're going to want to write that in a decimal form. So 0.16. So our strength for our 72 would be 0.72. And then our mixture, according to our problem, is going to be a 30% mixture. So that would be 0.30. Okay, the number of liters, we just said that we were going to let the number of liters of our 16% solution be X. So we just need to put in an X. We just said for our 72% solution, it would be a Y. And then if you look back in our problem, I think it tells us how many liters of the 30% we get. It says Chung needs to combine the 16 and 72 to get 6 liters of 30%. So the number of liters of 30% we're going to have is 6. Now, the last column, in order to get the information in that column, we're taking the strength times the liters. So we're taking this column times this column to get what goes over here. So 0.6 times x is just 0.16x. So then we'll have 0.72y, and we'll have 0.30 times 6. If all of this stuff isn't really clicking or looking familiar, you need to go back to Chapter 3, Section 4. That's where we first covered the mixture problems, and you really need to look over that video and the handouts and the whatever else material you need to do on those so you can do this problem. Okay, so why did we do the table? We do the table because in this column and in this column we have our equations. These are our system of ordered pairs, or excuse me, system of linear equations are from this column and this column. Because now what you're doing is you're saying this one plus this one equals that. So we're saying x plus y equals 6. Similarly, we're saying 0.16x plus 0.72y equals the 0.30 times 6. So we have the 0.16x plus 0.72y equals 0.30 times 6. Right there is our order, is our system of linear equations. So with the decimals, it never looks good, but with decimal problems, you probably want to do the substitution method because then you don't have to multiply by decimals. So we need to solve this first equation for one of our variables. So I'm just going to solve it for my y, which means I'm going to subtract my x over. So that would be y equals 6 minus x. So now, anywhere there's a y in the second equation, I can plug in 6 minus x. So I would get 0.16x plus 0.72, and then instead of y, I'm going to write 6 minus x, and that equals 0.30 times 6. Okay, now I'm going to distribute in my 0.72 to my 6 and my x. So I get 0.16x plus plus 4.32 minus 0.72x equals, and then 0.3 times 6 is 1.8. I'm going to add my 0.16x and my negative 0.72x, and that will give me a negative 0.56x. And then if I subtract over my 4.32, I get negative 2.52. Slide this up a little bit. Now I just have to divide both sides by the negative 0.56. If you do that, and you type it in your calculator, you'll get 4.5. And x stood for the number of liters of 16% solution. So we have 4.5 liters of 16%. So now we just need to figure out the number of liters of our 72%. But luckily we had a nice equation that said y equals 6 minus x. So now we just have to plug in the 4.5 in for that x. So we get y equals 6 minus 4.5. So y equals 1.5. And that is the liters of 72% solution. Again, I can promise you there's always a mixture problem on your final exam. So if you struggle with these, please take the time to learn how to make this table up here, because this table is so nice on how to solve these problems. Because once you get the categories, it has your equations already laid out for you. So go back to Chapter 3, Section 4, and look back over those problems. And make sure to use your similar exercise button in the Course Compass site to get you a whole bunch more of these problems. Okay, so let's go on to our very last problem. And it is an investment problem. Let me pull up my paper again. Okay. This says you invest $10,000 into 2 accounts, paying 4% and 6% annual interest. If the total interest earned in a year is $410, how much did you invest at each rate? Okay, so we need to find out what our unknowns are again. So that's going to be how much did we invest at each percent. So amount at 4% and the amount at 6%. Those are our 2 unknowns. So again, I'm just going to label the first one as an X and the second one as a Y. And we don't know how much we are putting in each of those, but we do know that we are investing a total of $10,000. So if we have X plus Y, it should be $10,000. We know that from the very first part. Now, we don't know how much we're investing at each, but we do know that our total interest for a year was $410. So we're going to get $410 from both of our investments. So that means we're going to take 4% times our X. Remember, you have to write that as a decimal. And then you're going to add to that however much you're going to make at the 6%, which is the, sorry, I'm going to rewrite that because I crammed it in. 0.04x plus 0.06y equals the 410. Because remember, interest works, you're taking the percentage times however much you're investing. So this right here represents the interest at 4%. And so this over here represents the interest at 6%. And for the total year, you earned $410 from both. So that means you have to take the interest at 4% and you have to add it to the interest at 6% in order to get your 410. So those are our 2 equations. So that is our system of equations. Now, again, because this one has decimals, I'm going to want to do the substitution method. And so I'm going to want to solve for either my X or my Y. And in this case, I'm going to solve for my X. So I'm going to just subtract my Y over. So that would give me X equals 10,000 minus the Y. And then I'm going to rewrite our second one just so it looks nicer. So right there is our system of equations. Now anywhere that there's an X in that second equation, I can just plug in 10,000 minus Y. So I should have 0.04 times 10,000 minus Y plus the 0.06y equals 410. I need to distribute in that 0.04 to both the 10,000 and the negative Y. So that'll give me 400 minus 0.04y plus 0.06y equals 410. I'm going to combine my like terms. So it's 400 plus 0.02y equals 410. Subtract over your 400. 0.02y equals 10. And then you need to divide both sides by the 0.02, and you get y equals 500. Remember, y is the amount invested at 6%. So you're investing $500 at the 6% mark. Okay, and now we need to find out our x. So our x was 10,000 minus our y. So we just need to plug in 500 for our y. And you get x equals 9,500. And that's the amount you invested at the 4%. Again, if you need me to rework those, you can just rewind the video and listen to me rework them again. If you just want to see the steps written out, you can open up the 9.5 handout answer key and look at them there. And then when you're doing your homework, make sure you utilize the you can do the help me solve this button if you get stuck, but then definitely utilize the similar exercise button so that you can see more problems and get more practice, because you will be seeing these problems on the final exam. So good luck with your homework and good luck with your quizzes.